Hello everyone. Today we are going to learn about electron transport chain. First, we need to know where this electron transport chain is located. Electron transport chain is located in the inner mitochondrial membrane. As you can see here, it is the intermembrane space and this is the mitochondrial matrix. So this is the inner mitochondrial membrane where the electron transport chain is located. Electron transport chain is composed of 4 complexes, as you can see here: complex 1, complex 2, complex 3 and complex 4. Apart from these complexes, there are some other molecules that are very important to this electron transport chain. They are ubiquinone, denoted in Q, and cytochrome C. We will talk about their roles later. First, let's talk about complex 1. This is also called NADH dehydrogenase. As the name suggests, it removes H from NADH plus H positive. So NADH transfers its electron to this complex 1 and becomes NAD positive. So when this complex 1 receives an electron, it becomes a high energy complex. But as we know, nothing wants to be in a higher energy state because everything wants stability. As we all want stability in life, these complexes, they also want stability. So to achieve this stability, this will transfer this electron from it to ubiquinone. As we said, ubiquinone is a very important part of electron transport chain. This is a hydrophobic molecule which can travel between these inner mitochondrial membrane, which gives it ability to collect electron from both complex 1 and complex 2 and transfer it to complex 3. So this complex 1 transfers its electron to ubiquinone. But what do you know? What's the flow of electron? It's electricity, right? So using this electricity, this complex 1 pumps proton from this matrix side to the inner intermembrane space. We will see the use of these protons later. Now to complex 2. This is also a complex of electron transport chain that has another name, that is succinate reductase. So this reduces succinate by accepting electrons from succinate and making it into fumarate. But unlike complex 1, this doesn't have any ability to transport proton to the intermembrane space. Rather, it transports its electron to ubiquinone, just like complex 1. Now, the ubiquinone that has received electron from both complex 1 and complex 2 transfers the received electron to complex 3 and becomes quinone again. When this received electron from complex 1 and complex 2, this became quinol. If you see the structure of this quinone, it has 2 ketone groups, that is O double bond. But when this received electron from complex 1 and complex 2, it was transformed into quinol that had 2 hydroxyl. But when this transfers its electron to complex 3, it becomes quinone again. Now, the complex 3. Complex 3 received this electron from this quinone and rose to a higher energy state. But as we said earlier, nothing wants to be in a higher energy state. Rather, it transfers its electron to this molecule, cytochrome C. And while transferring this electron, this complex 3 also have an ability to pump proton. So using the energy that it gained from transferring the electron to cytochrome C, this also pumps 4 protons from the matrix side to the intermembrane space side. Now this cytochrome C has received electron from complex 3. It has been transferred into a higher energy state. This now travels through this intermembrane space Just like quinone could transfer through this inner membrane, the cytochrome C has an ability to transport between intermembrane space. So this travels through this intermembrane space to complex 4, where it releases the electron to complex 4. Now that complex 4 has received the electron, it has some energy. What complex 4 does is uses this energy to transform these 2 protons and oxygen into water. And while doing this, this also pumps 2 protons to the intermembrane space from the matrix. So we see that 10 protons have been pumped in one cycle of electron transfer. These protons play a very important role in ATP synthesis. As we see here, this is an enzyme called ATP synthase. This is not a part of electron transport, rather this is oxidative phosphorylation. When these protons were pumped into the intermembrane space, a proton gradient was created in the intermembrane space. But this proton gradient stores energy because there is an electrical potential, as you can see here. Inside becomes negative and the intermembrane space, that is the p side, becomes positive. Due to this change in charges, there is an electrical potential. Also, there is a chemical potential of pH, because we know when there is more hydrogen positive, that means there is a low pH. So there is a low pH in the intermembrane space and there is a high pH in the matrix side. These two serves as a reservoir of energy. So when these protons return to the matrix side through this ATP synthase enzyme, this ATP synthase enzyme uses that energy like a dam that we use to produce water electricity. We reserve water in a higher position and we flow that water to turn turbines to produce electricity. This is absolutely same. These protons come through this ATP synthase enzyme and this gives the ATP synthase enzyme enough energy to transform ADP, an inorganic phosphate, to ATP. Thus, this electron flow pumps proton and this proton in turns creates enough energy to synthesize ATP. Thus, the ATP synthesis works by electron transport. So, that's a simple overview of electron transport chain. We will learn about the complexes individually in later videos. Thank you very much for watching today's video.